Welcome to Dare, the show for entrepreneurs who dare to shape the future. Brought to you by Darwoft, the superpower tech team that can make your ideas a reality, and by the Oregon Entrepreneurs Network. What do you dare to dream?
The Dare Show is excited to welcome Vadim Manolio to the show. He is a lifelong technology presenter and marketer. He's helped people with exciting technology all across the U.S. He most recently was at Sony, leading a business development and marketing team. And now at SensoBright, he drives forward with a passion for people and technology. And he really is beginning to answer the question of why can't robots feel the same way that humans do? So he's focused on tactile sensing, and he's doing some fantastic stuff there. He lives out in Beaverton, and we're excited to hear more about his technology and his company at SensoBright.
Ned, thank you so much for having me. It's really a pleasure, and it didn't take very long from meeting to the point that we're actually here talking about the exciting technology. I'm happy to
Yeah,
be here and answer any of the questions. Of course, learn little bit about your background with the technology and any adjacent tech as well.
fantastic. So we actually met at Demolicious. And so Demolicious is a pitch competition here in town. I'll just ask out of the gate, what led you to Demolicious? And why were you pitching there?
Now, of course, well, Demolicious is a place where you get not just passion and talents, but you get to meet incredible people with incredible tech. As I found out,
Mhm.
many kinds of tech. I learned about Demolicious because I thought, wait a minute, I could learn about the interesting people in Portland. And sure, there's always a chance to meet future partners. But most importantly, technology and people are what drives me to an event. Whether it's related to what I do isn't always necessary. I just love to learn new tech, new people, and learn from those people. Sometimes you get partnerships, great. If no partnerships, still great. I still made a friend and learned new technology.
Yeah, the Portland startup community is so self-supporting and supporting of each other. It's really fantastic to see, isn't it?
It is. Josh is a big contributor to it. Josh is the person that puts together, organizes Demolicious, and he's helped a lot of people get noticed. For Sensabright, Demolicious was just a chance to say, hey, if you haven't seen what we do, if you haven't heard about us, here's who we are, here's what we do, here's what we bring to the table. And Portland brings that together with a number of different steps and events. So I'm happy to at least jump into Demolicious for a brief moment there.
Yeah. So, what does SensoBright do? Can you sum this up in a few sentences?
Of course, in a glorified sentence, sense of right, we teach robots how to feel. Machines today, they can see better than us with cameras. They can hear better than us with microphones. But for some strange reason, tactile sensing has been put on the back burner. With all the advent of physical AI and all the robotics teams bringing robots into the real world, working side by side with humans, it is ever more important to develop a methodology that we bring to the table and everybody else is trying to bring to the table, teaching robots
Mhm.
what do things feel like in the real world? How do we work with humans without endangering them? And better yet, with being able to learn from the world around them.
Yeah, so as you may know or not know, I actually worked on sensors at Intel, and we shipped a sensor framework that's now used on millions of devices around the world. So, one question that I have is how do you make a robot feel the way a human being does? Because the sensors we were working on were things like temperature or pressure or other things. But frankly, it's at a level of refinement that's far different than the refinement of the human fingerprint. So that's the problem you're trying to address, right?
Yes, thank you for that introduction, by the way. It was a very generous transition, too. One of the things we often bring up humans have over 240 mechanoreceptors per one
Uh huh.
centimeter at their fingertip. And that's the metric we go by. What we do is we bring a technology that works most close to human skin. And that's the missing component in robots. And I'm happy to say how and why. And that is the missing component that separates capacitive technology and other, piezo-resistive, whatever it may be, from what we do. The method that we bring gives them the robots the ability, any machine, the ability to say, hey, we can make a sensor as small as two fibers, a fiber optic
Really?
and a fiber optic out.
Wow.
Doesn't give you resolution at that point. If you want resolution, we offer our fingertip sensor. Let's say, and I'm happy to go into the tech, but I'd love to at least start with the idea fiber optics, and
Hmm.
it's a vision based system. Happy to jump into any part from that, of course.
So it's a vision-based system. That's fascinating.
Oh, absolutely. We are what we do differently is most teams that use capacitive. It's essentially what you imagine. It's an array of sensors and an active component. For us, it's SensorBright. Now that it's a visual podcast, what we do is we use a silicon gel at the touch point. The silicon gel, when it touches something, it takes the shape of that object. You press it in, the pressure makes it change the shape of the object to the silicon gel, which is very, very, of course, skinny, and we can make it to whatever needs the end user has. Silicon gel is very skinny, takes the shape of the object. To the back of the silicon gel, we ran an array of fiber optic cables. So if somebody is from a robotics team goes, hey, we need our robots to know, are we gripping a thing? Is the object slipping?
Mhm.
We offer a 20 by 20, so it's a 400 fiber optic cables running up to the back of this specific patented, what we call magic silicone. And now the object is impressed upon whatever the robot is touching or pressing. And one side of the silicon cables, we shoot a laser or a light. And the other end of the silicon cables delivers that image down the pathway. If you are in, let's say, a humanoid robot, your sensing happens here, but there's no active components at the touch point. That's the silicon gel and fiber optic cables carrying the light information down to, let's say, a foot away, where it's now
Mhm.
being received by a CMOS image sensor. And after it's received by the image sensor, then it's sent forward down to a machine computer for whatever processing or AI you need to run. So essentially, silicon gel, fiber optic cables, bringing that light information from, if you're on the technical side, 0 to 255 black to white transition info, sending that value information to the, pardon me, light to CMOS sensor, makes that decision, and your robot gets the exact image of whatever the shape is of the object it's touching instantly. And there's other reasons why we're happy to use fiber optics as opposed to some of the other ways of bringing information. But wanted to at least start with introducing what is SensaBright core technology and how it's different than a lot of the other things that we see on the market today.
Well, my understanding too is that you have what is it, 160 patents too. Is that true?
Thank you so much. So we have, yes, at this point, over 160 granted patents, and a lot of them are international. It took many years to get to where we are today. And the professor that started this company invented this technology. Professor Dr. Utku Buyuksakin started in Turkey. And very happy to say he has been on the news in Turkey with some of the comments even NASA made about SensaBright and the inventions. Moved to the United States. Silicon Valley was one stop, and Portland, Oregon, Beaverton is where we now have our US and global headquarters. 160 patents to get to where we are today. And of course, this isn't the only methodology we developed. This is just what we currently bring to the markets and bring to automation, human machine interface, as well as medical fields too.
Fascinating. Okay. So currently, are you in market with medical fields or are you still in early prototype phases?
Medical is something that's so we are not currently in market with medical fields. There is
Okay.
research that, let's say, I don't know about consumer medical, but let's use the term consumer medical. Let's talk about research in hospitals. My goal with SensaBright, one of my main goals, is to bring it to research on the kind of research we see. I will say this, and this is going to be the only thing I'm going to try to make intentionally as ambiguous as I can. There are areas where there is medical research with our technology that I cannot talk about, and I intentionally don't ask. So, yes, there is a big step forward in areas that I can't mention, can't talk about, but outside of that is my hope to contribute to bring SensaBright to medical, to OHSU, to Providence, to any of the US wide medical schools. And where it's, I think, the most usable immediately is since All we do is take a thing that exists, like retrofitting a
Hmm.
laparoscope, something we actively demonstrate, by the way. And the laparoscope cannot have a lot of space taken up because you're working with people with live tissue. So at the very edge
Hmm.
of a laparoscope, we outfit with our fiber optics with the gel, which gives sensitivity. So now a surgeon 1,000 miles away could tell to great detail if it's a tissue that's the right level of softness or if it's a concerning tissue. Now, as a technical team, we cannot do that research. As a technology company, we cannot do that research, by ourselves. We do need research as well as active development partners, and that's something that I'm working very hard on to build those partnerships.
Fantastic. So your go-to-market is building out these partnerships and these relationships with people who would use this technology, right?
That is exactly right. And
Okay.
automation and robotics. That's the ready side. The ready side is robotics company, anybody has a factory, especially in assembly that goes, I need my robots to know what they're grabbing
Yeah.
beyond if they're grabbing. That's ready to go. The medical side is going to take years of overcoming a lot of different steps, approvals, and research, of course.
Yeah. So what's fascinating about this too is that there is a convergence right now of AI and robotics. People are trying to put AI into robots with mixed success, but really robots are emerging as a real growth area. Is this where your kind of tactile world is going, that you're building robots with hands that can feel, or are you building like humanoid robots, or are you building more robots for factory floors or for picking up eggs in sorting facilities? Like, which direction are you going? Or maybe that's a false distinction.
Great. No, it's definitely a good question. So, the most applicable place for Sensabrite that's ready today, that we're happy to generate any amounts of, as they say, units on shelf, is fingered grippers. So, end effectors, robotic finger grippers. The, I think, easiest use for our technology, and we are a core technology company. We developed a new tactile touch modality that can be used in many
Hmm.
ways, of course. Easiest way to use, and the teams that we're working with right now are both assembly as well as research, and that's something that we can launch any number of partnerships going forward. Now,
Hmm.
the interesting part is this technology, because we're using fiber optics going to a gel, there is one more thing that the current technology we have offers. What if you remove that gel? What if there's
Hmm.
no gel at the endpoint? Now you have a fiber optic, I'll call it naked, shooting out a, let's just say, light or a laser. If you, with that specific use, there's nothing stopping the light from leaving. So the second use that the same core technology we make is proximity sensing. One of the
Hmm.
clients that we work with requested, "Hey, I get that we can make a gripper that now the robot knows what it's grabbing. Now, what if there is one more question? If a camera, most robotic systems today are vision based or something related to vision. What if the line of sight of the camera is blocked and you now no longer see, your robot has to make assumptions or be programmatically told to approach an item, but it can't see anymore? Well, we gave a
Mm.
solution. The same technology that enables you to grab and feel in great detail, if you shoot those fibers to the side of the gripper, you can now tell if it's approaching something with proximity. And we do that on the
Interesting.
processing end. So one side of the gripper has the actual touch segments, which is where it recognizes if it grabbed an object or if it's too soft or if it's an egg, if it's cracking. The second part of it is when we shoot the same cable, not shoot, when we have the fiber optics pointed outwards, we are now sensing proximity if we're approaching whatever the object is. Now, last year, it was fun to demonstrate our sensors at conventions, from humanoid robots, either Summit or Forum in Seattle, to Silicon Valley humanoid robot. Again, Forum or Summit. I get those two confused. Last year, it was impressive enough to see mechatronics and engineering teams see how sensitive our technology is. But we
Mm.
also launched SensaBright AI, which we don't lead the conversation with this, to be able to tell what an object is. So not only can the
Mm.
robot now grab a thing and know if it's slipping, which has a lot of value to any company that touches, moves, pick and place, pick and pull accuracy, we now teach machines what objects are by touch alone. And
Hmm.
that opens up its own use case set.
Yeah. Fascinating. So you can actually teach a machine what something feels like, right? Is that what you're saying?
Yes, it has a visual as it grabs an object, gel conforms to the object, and of course, the machine gets an image of what the gel detects by touch. CMOS
Hmm.
sensor turns that into a visual, and because of years of doing that, we developed a actually fairly simple way of teaching, especially in a closed set. It's something that we don't lead the conversation with this, but we're always happy to show and demonstrate is we can do not just edge, but we don't need a Wi-Fi connection. One of the times we were challenged to teach the client's machine what objects were using SensorBright AI. They first said, "We don't believe you." We said, "We can teach a robot what
Hmm.
things are faster than your team can." They said, "Again, we don't believe you." And they brought us a number of items in the office. They found a clicky side of a pen. They found a cable, and they found a third object. And within a couple of minutes, I want to emphasize minutes, because most AI technology that it takes to teach a machine the methods they have now takes lots of energy, lots of money, takes lots of time as well. We were able to do it with just our SensorBright AI on a computer with
Hmm.
no Wi-Fi connection by touch, because the computer gets exactly what the object is. And in a closed
Hmm.
set, it's very simple. Of course, in an
Hmm.
open set, we're not talking about open sets necessarily yet, but we are actively developing the ability of I've never touched this object before. What can it be? We currently have I've already touched this object. I know what it is now. And it takes a little bit of motion around to go, okay, I now have enough data. I understand what the shape I'm touching is now. It's going to show the more limited choices that it thinks it might be, a little more information, and it goes, oh, I know exactly what it is. And I think online we have the finding which exact watch of a set of watches. One of the videos we show on the internet is being able to discern of a set of 10 or something watches, what exactly it is.
Fascinating. Yeah. So you're teaching machines.
We are. Absolutely. And the pitch that somebody pointed out is, wait a minute, are you saying that SensorBright could teach machines what an object is by touch? Yes. We're also saying it's faster and much cheaper. And to me, it would be impressive if somebody said, hey, we can teach a robot what things feel like, but the person walked away going, wait a minute, are you telling me you guys have a brand new way of saving money and saving energy costs for companies? We go, yes, we do, but please focus on our brand new tactile sensing core technology. Please walk out of this
Hmm.
conversation with that over the AI conversation, which is important, but I would say secondary to our sensors and when it comes to SensorBright and what we're offering and delivering to the market.
Right, right. Fascinating. So, what led SensoBright to be here in Beaverton or here in Portland? Like, what's unique about this area?
Of course, actually, it's a lot simpler. It's not even just when the first step was in Silicon Valley area. The temptation is to say it's expensive, but everyone knows that. Actually, family, Dr. Professor Utku Buyaksahin, he has family members here, including his
Hmm.
brother and his sister-in-law, who teaches at OHSU. So ultimately, family led to Portland. Portland's nice, delicious food. My favorite part is amazing nature. Oregon and
Yeah,
Portland have just breathtaking nature. If I had infinite time and money, I would just be off in forests and by the ocean near the forests all day long.
fantastic. So, the SensoBright mission is clear, the IP is clear. Where are you at as a company right now? How many people do you have on board? Are you kind of gathering steam for your next big move? Are you landing some major customers? What's next?
Yes, we are working with some recognizable companies, and yes, there's more that are coming on board. What's next is the segment that I mentioned that I gladly ask nothing about has essentially said, yes, Sensa Bright is our next move is we are likely to have a factory, we hope in Oregon. that is something that I personally hope. A second factory, that is to say.
Hmm.
Realistically, it will likely not be in Oregon. My senses are picking up it's going to be on the East Coast. Sensabright continues as the Beaverton basis, as a global and US headquarters.
Hmm.
Our next step is East Coast factory, or at least I think it'll be an East Coast factory that is right now being talked about very heavily. For myself, I want to find as many robotics and automation teams to bring into the Sensabright ecosystem and benefit from what we offer. And my personal hope is to build medical partnerships, which I take any help if you're an OHSU researcher hearing, wait a minute, no active components. That means you can work in water, in liquids. Absolutely. So it makes it enabled for medical. No active
Hmm.
components. That touch point means EMI, we have no issues, electromagnetic interference of any sort, which let's say you're a robot working in a factory carrying batteries or any giant machinery, you're going to have electromagnetic interference. So not a problem for Sensabright sensing technology, whether it's a robotic finger gripper or a giant machine that turns cars, whatever use may be. Or for the medical
Hmm.
teams, it's scalable and does not have a problem with liquids, doesn't increase the size of an instrument besides maybe a couple of millimeters at worst. So, Sensabright next steps. We are going to expand with most likely a East Coast factory, although there's still a chance it's Oregon. We will see. I prefer it's Oregon, but realistically, it'll probably be East Coast. And the
Yeah.
next, landmark for myself will be working with medical partners because while the company leadership has active medical partnerships that are growing very, very successfully. For myself, I'm yet to make all the connections I need to make us succeed here at the local level on getting us into medical, surgical, for instance, research.
Fantastic. So you really have a line of sight on what's going to happen next in this growing field, right?
Yes, but it's changing so fast, Ned, from the AI conferences from Silicon Valley to Seattle, I could see how fast everything's moving. And to be honest, things are a little bit tough to predict. The biggest trend I see is physical AI combining robotics companies with AI teams. And we've
Mm.
had a chance to talk to a number of both robotics and AI teams, and it's great to see the responses. But I could see the market changes very quickly, and you must always follow what's coming next and how it's impacting your roadmap. I think it's true for any industry, but this seems to be the industry. And I've talked so much, I really would like to find out. I mean, it's clear you have an engineering pathway that took you here. You're a major technology fan yourself, and you've worked on sensors with Intel. I'd love to hear your thoughts, and I'd love to hear any part of your story as well, and maybe even how it relates to what Research Sensabright does. And I know this is your show, but
Great. So, Vadim, you had just asked about my background in this. I guess what is fascinating about this is that the principals at our company, Darwoft, actually work together on sensor frameworks now deployed by Intel around the world on hundreds of millions of devices. So our CEO, Cecilia Mariani, is a leader in sensor technologies. And she and I worked really closely on sensor technologies while at Intel. And I was really gratified to be part of her team here, working on the business side of the house, but from a very technical angle. So yeah, worked in sensors for a number of years and have a great deal of respect for how difficult that can be. I mean, back 20, 30 years ago, we had computers that were incapable of actually understanding the world other than through a mouse click or a key click on a keyboard. And now we have computers that can sense the world. And you and I have both traveled through this vast change in how computers can interact with us. And I'm curious, as you look at the future, do you see a future where computers have just as much sensing capability as humans? Do you think we're converging on that someday?
well, you know, we are inching our way to bringing the tactile side of that in a broader sense. there is a complete reversal of how each us, the humans, and the machines that we work with learn the world. First, we're born with sensing ability. The first 6 months, actually, a baby explores the world by touch alone.
Yeah.
There's before the eyes are formed, before there's no LLM in a baby. You're touching things and you're learning things just by touch. So you
Yeah.
come into this world knowing hey, things are 3D physical. Furthermore, some things are pleasant, some things are not pleasant. And a robot has been seeing things and hearing things, and we just had this, I dare not say awakening, but maybe awakening of the general public to the power of LLM and small language models. So their technology is approaching the question of touch from the exact opposite perspective. Where does
Mm.
that take us is a great question. We start the world by touch and get to, oh yeah, talking, we'll get around to that. Thinking, God forbid. But robots, on the other hand, they started with, we're processing a lot of information, neural networks, now modern LLMs and conversation chatbots, this and that. And sensing is almost the final step. To me, this is the final frontier. Aya Durbin from Boston Dynamics just had a presentation where they talked for like 40 minutes about the future of robotics. One of their last points was they deliver that touch, tactile sensation is, as we say, the final frontier. Jan LeCun, I think he's with Meta AI, and pardon me if I'm confusing, like genius.
No.
Jan LeCun specifically said that we are on the next steps of robotics when robots can feel with their touch. And in fact, most teams arrive to that conclusion. So not to step too far away from your just now question, but we are just now getting to, touch is important. And robots are just now, after all these years of development, are going, touch? Yeah, I guess that's a thing. We're in a completely tactile world with 0%, well, I'm going to arrogantly say 0%, but close to 0% tactile data in a completely tactile world. Humans start knowing this, robots seems like they're just getting there. And if we're just getting there, how long until we're matching human capabilities?
Yeah. So this is the beginning of a huge wave of development and of change in our society, and you're riding the crest of that wave. Well, last question for you, Vadim. What do you dare to dream? Is that your dream that robots will be fully sensory?
I dare to dream that despite how new and interesting robotics are, despite all the advancements, there is going to be a future where it's harm-free, where the robot knows, hey, this is a good touch, this would be a bad idea. I dare
Hmm.
to dream that our sensing technology for proximity can be in every machine. We work under soft surfaces, we work under whatever, on a curved surface, we work inside liquids. So, as a core technology company, we hope to be everywhere automation is without bringing the harm, and furthermore, with bringing the knowledge and learning. And one little drop to that. I personally am heavily bought into the surgical side and bringing our technology to enhancing surgery. I have to say, I unfortunately know and have to know how important surgical methodology is. And I'm not a PhD in this or anything, but I know by practice how it would change the world for the better if we were able to give the ability of touch and replace palpation for a doctor that's right next to you or a doctor that's 1,000 miles away. And that's a big part of my dream right now as a person and with Sensible, of course.
That's a great end to a great discussion with you, Vadim. Really appreciate your time and the dream that you shared with us. Thank you.
Thank you so much for your time, and I'm happy that we got to spend it here together. Thank you.
Thanks to our guests today for their great insights on Dare, the podcast for innovators, entrepreneurs, and startup leaders. If you'd like your story to be featured on Dare, just contact us at info@darwoft.com. Dare is brought to you by Darwoft, the tech team that can make your vision a reality.